Welcome to the DIY Honda Garage channel. DTC P1AF0 indicates an input power A voltage out-of-range issue specifically for the Honda Civic models from 2022 onwards. This error code signifies that the power control module, PCM, has detected that the voltage in its power supply circuit has gone beyond normal limits. The PCM acts as the central unit managing various engine functions, and any disruption in its power supply can lead to erratic engine performance or failure to start. The location of the PCM is typically found in the engine compartment, where it connects to various vehicle components. It's critical to address this code promptly because unresolved issues can lead to further complications throughout the electrical systems in your vehicle. If the voltage readings are out of range, it could prevent the PCM from functioning correctly, causing performance issues. The core issue, represented by DTC P1AF0, relates to the power control module, PCM, which is crucial for engine management and various electrical systems. The PCM depends on a stable power supply, typically derived from the vehicle's 12-volt battery circuit. This circuit plays an integral role in ensuring that the PCM receives the necessary voltage to perform its functions accurately. The PGM-FI main relay functions to switch power to the fuel injection and ignition systems by controlling the flow from the battery. If the power supply voltage goes out of the specified range, the PCM interprets this as an abnormal condition, consequently storing the P1AF0 code. This could be due to various reasons, such as loose connections or damage, which necessitates a thorough investigation in the areas where the battery and PCM terminals reside. Several potential causes can trigger DTC P1AF0. First off, if a high-voltage battery such as a 24-volt system is connected to the vehicle, it may result in an out-of-range voltage reading for the PCM. Secondly, corrosion at the battery terminals is a risk factor and can affect the quality of the electrical connection, leading to voltage discrepancies. Thirdly, loose ground cable connections in the engine compartment can also disrupt the flow of current to the PCM. It is critical to inspect those components, as any of these anomalies can create the conditions for the voltage to deviate from its expected range, ultimately leading to erratic vehicle behavior or malfunction. When DTC P1AF0 is stored in the PCM, several symptoms may arise indicating malfunction. Erratic engine performance may be evident, manifesting as stalling or unexpected shutdowns while driving. Additionally, the vehicle may fail to start due to inadequate power reaching critical components controlled by the PCM. If there's a persistence in voltage range issues, various electrical systems within the vehicle may also start behaving erratically. Such electrical issues can include non-functioning lights or sensors, adding further complexity to the diagnosis. It's vital to recognize these symptoms as they serve as vital cues that something in the power supply system needs to be addressed immediately. The first troubleshooting step for DTC P1AF0 involves checking if a high-voltage battery is connected to the vehicle. This is crucial, as an external high-voltage supply can falsely trigger the error code. Next, inspect the battery terminals meticulously for any signs of corrosion or damage, as corrosion can prevent good connectivity and affect voltage levels. Furthermore, ensure that the ground cable connections in the engine compartment are adequately tightened and not showing signs of wear or corrosion. Problems in these areas are common culprits that can lead to discrepancies in voltage readings being relayed to the PCM. By addressing these initial checks, you can significantly reduce the chances of further complications. The second step in addressing DTC P1AF0 is to perform a test on the PGM-FI main relay 1. This relay is critical for supplying power to the fuel injection and ignition systems, so ensuring its functionality is vital. Following this, conduct an inspection of the +B IGP circuit, which is responsible for delivering power to the relay. Checking the FI main RLY out circuit is next. Any open or shorted wires may lead to a failure in transitioning power, which can result in the DTC being stored. It's important to follow the diagram accurately while performing these checks to ensure that every involved component is functioning as intended, as one failure can cause ripple effects throughout the vehicle's electrical system. The third step in the troubleshooting process involves inspecting the FI main RLY out for open wires. If this circuit is compromised, it can lead to failure in power reaching the PCM. Similarly, an inspection of the FI main RLY CL- wire should be conducted for the same reasons. Normal conditions dictate that there should be less than 1 ohm of resistance in these wires. Thus, if resistance exceeds this value, it could indicate a short or open circuit, leading to a loss of power supply to the required components. Documenting findings is crucial, as this assists in isolating any issues detected. If abnormalities are found, these should be addressed before proceeding, as resolving this layer is essential before moving deeper into the electrical diagnostics. For the fourth troubleshooting step, focus on verifying the FI_main RLY out for any short conditions. A short to ground would indicate a significant issue within the circuit that could lead to improper voltage flow. Ensure to follow the recommended continuity checks, where normal conditions should show more than 1 megaohm in this segment. Anything less will indicate a fault. It's also a good idea to inspect ground connections, as faulty grounding can lead to similar synergies that might affect how power is routed in the PCM assemblies. By conclusively checking these elements, it allows for a clearer understanding of where the malfunction lies, enabling a path toward effective repair. In this fifth step, inspect each component connected to the FI main RLY out circuit. This inspection should prioritize components one by one while reconnecting them to the circuit, watching closely for any abnormal readings or behaviors. It is vital to ensure that the external circuit remains functional throughout this process. By applying power between two connection points or components, it's possible to evaluate real-time data, especially when they are reconnected. The documentation of behaviors or faults in this step is immensely beneficial, as it contributes to honing in on the specific failures within the circuit, illuminating any faulty components requiring replacement or intensive checks. The final troubleshooting step involves conducting a thorough inspection of the PCM itself. After all other components have been evaluated and deemed functional, the diagnosis often falls back to the PCM if the issue persists. The process might include visual inspections for physical damage or corrosion on the module itself. Additionally, using diagnostic tools to check for signals and readings directly from the PCM can reveal faults indicative of internal failure. If found to be defective during this inspection, a replacement PCM may be necessary to restore functionality. This last phase is critical, as it stands to resolve the core issue if no other abnormalities are detected in preceding components. After all repairs and inspections are complete, it is essential to clear the DTC from the PCM memory. This action resets the system and enables real-time monitoring of the vehicle's performance without the previous errors influencing symptoms. A test drive follows, allowing you to observe if any of the prior symptoms reappear. It's crucial to remain vigilant during this phase, as certain issues may resurface only under specific load conditions or driving scenarios. Close monitoring of the vehicle's electrical systems and PCM activity will provide insights into the effectiveness of the repairs made, ensuring no reoccurrence of DTC P1AF0 suggests that the appropriate repairs and preventive measures have been successfully implemented. Preventive maintenance is vital to avoid issues related to DTC P1AF0 arising in the future. Regularly inspecting battery terminals and connectors can catch potential corrosion early, ensuring a reliable power supply to the PCM. Make it a routine to ensure that all ground connections throughout the engine compartment are secured tightly, as loose connections can lead to similar DTCs in the future. Furthermore, routinely checking voltage readings throughout the electrical system can help identify any fluctuations or abnormalities early on, allowing for timely repairs. Consistent preventive measures do not just serve to maintain the vehicle's immediate functionality, but they can ultimately prolong the life of critical electrical components and avoid costly repairs. In conclusion, DTC P1AF0 points to an input power voltage issue, primarily concerning the PCM within the Honda Civic 2022 Plus. It underlines the importance of ensuring that electrical components like battery terminals and relays are in good condition. Focus should be on systematically diagnosing each component, particularly the PCM and its connections, to confirm their functionality. Replacement of faulty components may be necessary to restore proper voltage levels to the PCM. Emphasizing regular diagnostic and preventive checks can help avert the reoccurrence of DTCs and ensure the vehicle operates efficiently and reliably. Please like and subscribe to the channel. See you next time.